We're building up to a multi-agent research assistant that ties together all of the modules in this course. And to build that, we just covered parallelization, which is an important controllability topic. And now we're going to cover subgraphs, which is another important controllability topic. So subgraphs allow you to create and manage different states within different parts of your graph. And this is really useful in multi-agent systems, like teams of agents that have their own state. So let's just consider a toy example. I have a system that accepts logs. It does two separate things. It summarizes them, it finds failure modes in them. And I want to perform these two operations in two separate subgraphs. So here's really the key thing to understand and think about. How does the parent graph, or in my case the single entry graph, connect with or communicate with the two subgraphs in terms of state, right? And likewise, how do the subgraphs communicate back to the parent graph? In short, this is done with overlapping keys. That's the key concept to understand. So here's a toy example from below. My entry graph, or my parent, has a key docs. I want both subgraphs to have access to docs. All I have to do is just add that key to the state of each subgraph. Easy enough. I want my parent to also access like the reports from each of the subgraphs so it can return them in the end. All I need to do is just have the report keys present in my parent state. So you can see the subgraphs can have their own state keys like summary or failures that we don't care about in the overall parent state, but as long as the key things I want to communicate between the parent and the subgraphs are present in both places, they can effectively talk. So in this case, docs, I want to communicate to my subgraphs, just make sure the key is overlapping, and I want the report, summary report, failure report, to be accessible to my parent, just make sure those are overlapping. That's really the key idea in constructing subgraphs, and we'll walk through that in detail right now. So let's actually make this concrete. First, I'm going to define what a log looks like. This is just a type dict, so nice and simple. Now let's define my subgraphs. So we kind of talked about it previously. Here's my failure analysis subgraph. It's going to have some state here. And I'm going to specify an output schema for the state. We'll talk about why that's interesting a little bit later. But we talked about that in a prior section. And what this does, this simply sets the output schema of the subgraph is only going to contain information that I really care about servicing back to the user at the end. Okay. Now this contains all the internal information I want available in this subgraph. So let's just draw this out and see what it looks like. So there we go. It's very simple. We get the failures, we generate a summary, and we end. And these are all just toy functions. It doesn't matter. It's just to illustrate the concepts. So there'll be some toy function that, takes in the logs and isolates the failures and then looks at the failures and generates a summary. Okay, so that's all that's going on here. So there we go. That is our failure analysis subgraph. Now we also have this summarization subgraph. And again, we're going to define our summarization state and our summarization output state. We're going to have this generate summary, which again is just a toy node here. Here's a summary generated, it writes back out to summary. And we have the send to Slack, which will, it's just, again, a toy function sends to Slack. Let's draw that out. Nice. Okay. So to add these subgraphs to our parent graph, all we need to do is this. First, let's define our parent graph state. Now you're going to see something interesting. Here's our input. Here are the cleaned logs, which are going to be passed to our subgraphs. These are what we want to surface to the user. So this failure analysis summary is produced in the failure analysis subgraph. This report is produced in the question summarization subgraph. Process logs are produced by both subgraphs. So in this case, I want a reducer because both subgraphs will be writing to the same key, process logs. Cool. Now you're going to see something kind of weird. Why does cleaned logs have a reducer? This is just the input to each subgraph. So let's go back and look at that quickly. If I go back to my subgraphs, you can see they both use cleaned logs. It's just a list of logs, right? And that makes sense. We're going to get logs in our kind of entry graph here. We're going to pass them to both the subgraphs. But why the reducer here? Why is that actually needed? So the interesting point is that both subgraphs' output state will contain all their keys, even if they're unmodified. So we're not actually modifying or returning explicitly cleaned logs. So we're not updating it explicitly, but it is present in the state of each subgraph, and it will be returned by each subgraph to our entry graph. And because of that, unless there is a reducer, that can cause a collision in our state key or state channel. So there's a really simple way we address that, which is that we used the output state schemas. So if you go back to our subgraphs, we defined this output state, which does not contain cleaned logs. Same up here, does not contain cleaned logs. And because we're using this output schema that doesn't contain cleaned logs, we won't expect any issue. Now, of course, they both do return process logs, okay? They both will write to that particular key, but that's fine because process logs has a reducer. So that's really the way to think about it. So actually, when we define our output state, or we find our overall state for the entry graph, clean logs does not need a reducer because it's not present in the output schema of each subgraph. And we're just going to add this one simple clean logs node here, and let's put it all together. Nice. So we're going to start. We're going to go to clean logs, and then we're going to run both of these in parallel, and then we're going to end. So let's go ahead and try that out. We'll take two dummy logs. We will pass them in, and everything runs. Very nice. So one other nice thing about subgraphs is they make your traces much more readable, particularly if you have large graphs with many important subcomponents. I'll show you that right now. So I'm in Langsmith and I'm looking at the trace of this subgraph right now, and you'll see something immediately that's pretty nice. The two subgraphs are encapsulated here, and they're collapsible. So I can open this up and look at what's happening under the hood. I can look at the various steps of this particular subgraph, likewise of the second subgraph, but they are nicely contained here. And if you imagine if I have a complex system with many components, I can easily collapse the common subgraphs together and kind of open them up and drill into them, but then close them back down when I want to look at other parts of the system. So it makes your traces a lot more readable when you're working with large and complex graphs.